The purpose of this video is to cover American call options with dividends, using the binomial. Now you might ask, why don't I just do an American call option without dividends and do the binomial? Why am I putting dividends in here? Well, for two reasons. One, we need to learn how to handle dividends. They're a special case, and we need to adjust the binomial tree for it, take it into consideration. And the second thing is, the reason why we're looking at an American option because with dividends is because, remember, it may be optimal to exercise an American call option early with dividends, and that's the main point of this. So we're going to build a tree of using an American option, and we're going to see along the way that it may actually be optimal to exercise the option early, meaning you're going to get a hold of the stock. You will own the stock before expiration of the option. You'll own the stock, and you'll be entitled to collect the dividend. So that's ultimately sometimes called dividend capture. Is that concept. So let me give you background on this option. The stock is 50, stock price. Strike is 38. So you can see the option is deep in the money. T is equal to 1 year, and we're going to do 2 steps. 2 steps implies that each step is is 6 months, half a year. The dividend is going to be $4, and it will be paid in 6 months. Dividend, $4 at 6-month period. 6-month point. R is 8%, or 4% for each part of the tree, each step of the tree, since it's 2 steps. Sigma will be 0.2231 or 22.31%, and U will be 1.171, and U meaning the up step. U meaning the up step will be 1.71, and then D, the down step, is going to be 0.854. Now, using this information, we can figure out what is the probability of an up move, and we can use that probability to discount our cash flows back. We'll do it simple. We won't do the arbitrage, with hedge ratios and things like that. We'll do it in a quite simple manner. Okay, so the probability of an up move is 1.04. That is 1 plus the interest rate for a 6-month period, which is 1 step, minus the down divided by the up minus the down. And the probability of going up is 58.7%, which means the probability of a down state equals 41.3%. So some preliminary background on valuing American options using the binomial is a couple of things. The first thing we want to do is we're going to decompose the stock price into its risky component and do a risk-free component. The risk-free component will be the dividend. We are going to assume that no matter what, the dividend will get paid. So it doesn't matter if we go up or down, what node we're at, the dividend will be paid in that node that we specify. So in the upcoming problem, we'll see a dividend that appears at the first node, and it doesn't matter if it's the first up node or the first down node, that dividend will be paid. So I'll show you that as we get to the problem. Now, the second thing you want to keep in mind is this bullet here. And it says basically at each node, we want to value an American option by first computing the European value, European option value, and then comparing that payoff, right? Comparing that payoff to the payoff of exercising the option. So if we were to exercise the option immediately, what would we get? We would get the stock price minus the strike on an American option, if we were to at any particular node and we were to exercise it, this is what we would get. We want to compare it to what the expected present value of the option is. The expected present value is the European value. So the rule is whichever is larger is the American value at that node. So we're going to compare SK versus the expected present value, which is the European value. Whichever is larger, that's the American value. So let me build the tree. Here's the tree. We're going to start off with the stock price, which is set for 50, but we need to make an adjustment. We're going to decompose the stock price into its risky component and its present value risk-free present value of the dividend, which is a risk-free component. So we're going to compute the present value of the dividend, which is going to be 4 discounted at 8% for a half a year. And so the $4 dividend today is worth $3.85. So we're going to back out the $3.85, $3.85, and we're going to take the stock as $46.15 today at the time zero node. Now we're going to grow that $46.15 by the 17.1% U. The U is 1 plus 17.1%, and that means the stock price here will be $54.04. And we're going to add to this the $4 dividend that's payable in 6 months, because this is the first node is at the 6-month period. So this total is 5804. That 5804 is the value of the stock just before it goes ex-dividend. And when it pays, as soon as it pays the dividend, it'll be worth 54. So all I did was I backed out the dividend here, and I've added it here, the actual $4 dividend. I'm going to take this 54. So what will happen is this stock will pay the dividend, and from this node on, I'm going to take this $54, because now this stock excludes the dividend at 5404, and I'm going to multiply it by the 1.171, and I will have a stock price of 63.28. The call will be worth 68.28 minus the $38 strike. It'll be worth 25.28. Okay. Now on the downside, we're going to take the 46 and we're going to multiply it by the 0.854, which is the D. Remember, we calculated D to be 0.854, and so this will be worth $39.41. And don't forget, we're going to have that $4 dividend, and so with the stock including the dividend will be worth $43.41 just before ex-dividend. It'll pay a second later, it'll pay this $4 dividend, and then it'll start growing down. It could grow downward or it can grow upward. If it goes downward, we're going to multiply it by the 0.854, and we're going to be at $33.67 for a stock price with a zero payout because the stock is out of the money. If it goes up 17.1% or it goes down, so it's only worth 85.4%, it'll be a recombining tree, and so you'll be at the 46.15. Okay, and the payoff for the option at that point will be 8.15. So now what we're going to do is we're going to take this tree and we're going to work backwards. We're going to take the expected value of this, means we're going to probability weight the call and discount it back by 4% to this point to figure out what is the value of the the European option. What is the value of the European option here? Then we're going to compare it to what would happen if we were to exercise an option immediately. Then when I start saying exercise the option immediately, I'm talking about an American option. And we'll see which is larger. Okay? And whichever is larger will be the American option value. Let's proceed. So the first thing I want to do is I want to figure out what is the value of the European call. What is the value of the European call in the upstate? And that is worth the probability of going up, 58.7 times the 25.28 in the up node right here, plus 1 minus 0.587 times 815 middle node here, divided by 1.04, and I get 1750. So the value of a European call at this point is 1750. I want to ask myself, what is the value of the option if I was to exercise it immediately right here? So I'm thinking from an American perspective, if I sat right here and just before the ex-dividend date, I could exercise this option when the stock is worth 58.04. What is the value of that payoff? Well, the payoff here, I'll do the calculation, it's going to be S minus K. It's going to be 58.04 minus 38. And that's going to be $20.04. Okay? And so the American option is worth more than the European option. And you might ask yourself, why is that? It's related to the dividend. It's the effective dividend. So that you can capture this dividend right before the ex-dividend date. Now let's do the same thing on the down node. What is the value of the European on the down node? Put a little D there if we like. That's European and D right here. European and D. So call option European D for down. And that's going to be, I won't even do the calculation here because it'll be multiplying by 0. So I'm just going to take the up node, 0.587. So I'm sitting right here. The up node is probability of 0.587 times the 815, discount it back at 4%, and aim at 460. Okay, and so the call for a European is 460 at this point, and it's nothing but the expected present value of the payoffs. Here, the expected present values of these numbers. Okay. Now we need to ask ourselves, what is the value of the option if we could exercise it? What is the payoff immediately? Well, it's going to be the 43.41 minus the 38 strike. And so the call option is going to be worth $5.41. So in this case, this option, like it was up here, the option is worth more dead than alive, so to speak, at this point. In this point, if you hold the option and let it live, it's only worth $4.60. If you exercise the option immediately, it's $5.41 is its value. The same interpretation applies up here. If you let the option live, it's worth $17.50. If you kill the option by exercising it, you're going to get a payoff of $20.04. So you can see that American options are worth more than European options when there's a dividend. If you did the same math with non-dividend paying stocks, you'd end up with the same value, and that would be a good exercise for you to do. You wouldn't see any differences here. So now we're going to back up and do the exact same calculation at this point at node 1. And we're going to find, you do the calculation here, we are going to find that the call for a European at the 0 node is going to be worth 0.587. So I'm going to probability weight the value of the European call. discount it back. So the value of the European call at the first node is, I should put an E there, that's an E, is $11.70 right here. Now what I want to do is I want to do two more things. I want to say, what is the value of the American call by discounting back the American call values? So I'm going to take the 541 to $20.04, discount it back at 4%, the weighted average, probability weighted average of that. Okay, and when I do that, I get C little a O, meaning call at, an American call at the first node times 0, and that'll be worth $13.46. So this option is worth $13.46, and that $13.46 is the expected present value of this number and this number from the American perspective. We have one more thing to consider in determining the value of the option, and that is, if we sat right here, we always have the ability to exercise the option. And so the value of the exercise, the payoff, would be S minus K. That happens to be $50. The actual stock price minus the 38 is equal to $12. Okay? Now, let's summarize. The value of the European option is $11.70. The American option is worth $13.46. It's worth this much alive, meaning you want to hold this option and let it, as an American option, you want to hold it and let it live, because the expected value of that today is worth $13.46. If you were to exercise the option immediately, it would only be worth $12. So the value of the American call is $13.46, and you let it live as an American option and hope that it goes up that the stock goes up and it's worth $20.04. But there's a gamble there. There's risk. It could go down. So there you have it. There's an American call option with a dividend using the binomial.